Welcome back to Smart Guy in a Bow Tie. It has been a while since I've posted a video. I wanted to start off today by going over evaluating functions. Now, I try to explain this in a way that you might understand, and then I'm going to explain it to a way maybe you're taught or see it in the classroom. This is a very procedural task, something that just requires a lot of repetition, and it's for a very practical purpose. So we're going to build up a story. So we're going to say this M here represents how much money that you make. So M is how much money you make. And that depends on how many dogs you sell. So let's say you operate a kennel of some sort. The dogs have had puppies, or maybe you have a shelter from somewhere and they supply you puppies as well that you're selling. And so the money that you make is dependent on how many dogs you sell. And that very much implies exactly here what's written. Now this right here is the name of this function. That's how this function works. It's your money, and it depends on how many dogs you sell. Okay? And so that's where this comes from. We're not going to do much with the name. Just like when you live your life and things happen to you, it doesn't change what your name is. It just describes a little bit about what's going on to you. All right? And that's exactly what's happening here. This is just a name. As things here change, the name stays the same, but it might imply what has happened. So money you make, depending on the dogs you sell. And so that would make D the number of dogs you sell. So let's try this out. I said here, what this says is, how much money do I make if I sell 2 dogs? That's exactly what this title is. So this is how much money I make selling D dogs. D being I have no idea how many dogs there are. Here is how much money do I make if there are 2 dogs that we sell. So what we're going to do is we're going to take the 2 that's inside the parentheses, because that represents how many dogs we sell, and we're going to plug it in everywhere I see D. So it's just a substitution kind of problem. All right, so the money we make if I sell 2 dogs. Well, we're going to square the 2 dogs, so 2 squared. What does that mean? It could mean that the shelter promises you that for every 2 dogs you sell, they will give you that many more dogs to sell. 3D, so it could be that $3 per dog at your own kennel. Okay, oops, excuse me, 3D, 3 times 2. I talk too much, and I make mistakes. So what we have here is the amount of money you make if you sell 2 dogs. So what I did is instead of D here, I put 2. And as you saw from a mistake, instead of D, I'm placing 2. Now 3D, that represents multiplication, so we're going to continue multiplying. That doesn't change. So here I got 2 squared, which is 4. And then here we got 3 times 2, which is 6. So the amount of money that we make by selling 2 dogs is $10. Okay? And again, this is a hypothetical situation. So for our practical use in a mathematics class, or in physics, or even in engineering, what we're going to do here is this is just a simple substitution. We call this evaluating a function. Okay, so we're going to take the number inside our parentheses that represents this variable here, the x, our independent variable. Okay, because the amount of money you make is our dependent variable. It depends on how many dogs you sell. The value of this function depends on x, right? So if we say x is -3, so our name changes. What's the value of our function if x is -3? Right here, we have -2 times x squared. So I'm just going to put this in parentheses, so remember it's multiplication, not subtraction, squared plus 6. Okay? And we simplify. -3 squared is 9. I'm just going to simplify it one step at a time so you can see every step. -2 times 9 is -18 plus 6, and then -18 plus 6 is -12. So the value of my function when x is -3 is -12. So this is an example of evaluating functions. Okay, So this is a little tutorial. We'll have some maybe guided notes on this, but I want to get this kicked off and started of how to evaluate functions. It's just a substitution piece. All right, good luck, and I will see you next time.